Okay, good morning, everyone. Today we're going to talk about quadratic equations. Now, quadratic equations, this is a new chapter for us, but we have dealt with quadratics before. So we should not have anything to worry about here in terms of quadratic equations. We're going to work on graphing these quadratic equations. We're going to work on taking a look at their graphs to tell whether or not they're positive or negative, and so on and so forth. The first thing in review that we want to go over is that a standard form of all the quadratic equations are written in the form of ax squared plus bx plus c. Okay. When graphed, the quadratic equation creates a U-shaped curve, which we call a parabola. Now, depending upon the letter A here, okay, which is going to be a number in our equations, depending on the number that replaces A, will determine the shape of our parabola. So what we're going to do is we're going to take a look at a couple different types of parabolas, and we'll be able to tell whether or not the shape of the U is that of a smile or that of a frown. So let's take a look here. We're going to want to delete this. So what we're going to do is we're going to trash that. All right, and we're going to take a look at different types. Let's just say, for example, we are taking a look at the parabola y equals x squared plus 2x minus 5, okay? And we're going to compare it with that of y is equal to negative x squared plus 3x plus 7. So what we want to do is we want to take a look at the first term here because that has our a term, okay? Now, we're going to differentiate here. If a is positive, like it is here, then the parabola opens up. Opens up, wow. So it looks something like this. Okay. If a is negative, like it is here, negative 1, then the parabola opens down. Okay. That like a frown upside down. Okay. So just keep a big point key notice here is if we're looking at A, okay, we want to make sure that we're looking in here and in here. That's going to tell us a lot about whether or not the parabola is opening up or down. Okay. Hit this with a little bit of an erase. The next thing we want to kind of take a look at is this new notion of what we call an axis of symmetry. And the axis of symmetry is going to be a vertical line. Okay. So we kind of need to think back, what is the equation that we can use to represent a vertical line? And if you don't remember, that's okay. We'll do a quick little review. There's all these little marks. Okay. Axis of symmetry. Axis of symmetry. And again, a vertical line. So vertical lines, we know, takes the form of an x equals a number equation. Okay. And the axis of symmetry is the vertical line that divides the parabola into two equal parts. And now we kind of need to talk about how we find this axis of symmetry. And how we find the axis of symmetry is actually pretty simple. To find the axis of symmetry, what we're going to use is we're going to use this following equation. X is equal to negative b divided by 2a. So this is super important. Okay. Two things you want to take away here is, well, actually three things. Your axis of symmetry is a vertical line, okay, that takes the form of x equals. And how we're going to find that is we're going to use this formula down here, okay? And just remember that it is a vertical line that divides the parabola into two equal parts. Okay, and the last thing we need to talk about is the vertex. And the vertex is almost like the turning point in the graph. Okay, vertex is like the turning point in the graph. Vertex. And that vertex actually takes the form of a coordinate, x, y. It's referred to as the turning point. Turning point. Okay. When it is, so let's just say we have two parabolas. One parabola has a positive a, cause a greater than 0. One has a parabola less than, or a is less than 0, negative. We are going to have a minimum here because this vertex is at the lowest point. The lowest, that makes this a minimum. Here, our vertex would be at the top, and we would call this the highest point. The highest, or otherwise known as the maximum. So we have the minimum and we have the maximum. Those are our vertex. Okay, and I'll show you guys how to find the vertex when we go through a couple of examples. So, taking a look here. Let's do an example. So, we're going to take a look at the following example. Y equals x squared plus 8x plus 15. Okay. And we're going to find a couple of things out here. First thing we're going to do is we're going to find out what the axis of symmetry is. And for short, what I'm going to do is I'm going to put A, O, S. And remember, the axis of symmetry is found by taking x is equal to negative b over 2a. Well, this is going to be equal to, well, negative b is going to be negative, and then I'm going to insert the 8 because that's b right there. Divided by 2, and a here happens to be 1. So this would be negative 8 divided by 2. So my axis of symmetry is x equals negative 4. Okay. Now what I'm going to do is I'm going to take this x equals negative 4, and I'm going to use this. So use to find vertex. Now what I'm going to do with the x equals -4 is I'm actually going to plug it in. I'm just going to take the express root, and I'm going to take this and plug it in for x. Everywhere I see x, so now it's going to be equal, y is equal to, okay, remember when we're inserting a variable, we're putting that in parentheses. Well, -4 squared, that's 16, plus, well, that's -32 plus 15, and I believe -16 plus 15, y is equal to -1. So now our vertex, well, we plug in -4 for x, and we got 1 for y. Okay, -4, 1. That would be our vertex. So now what we'll do for a sketch, and I'm just going to erase a little bit to have a little bit more room on my screen. I'm going to put the sketch right here. How we would sketch these outside of having a graph is, well, first thing I know is that A is positive. So I have an upward facing parabola. Okay. Next thing I know is that I have my axis of symmetry. And that kind of splits the graph in half. That's x equals -4. And the last thing that I know is that I have my vertex here. This would be called, we would have this as a minimum, and that occurs at the point -4, 1. Okay, I'm going to try to get through one more example, almost kind of like a speed because I'm limited to 15 minutes on this video. If I could erase a little quicker, that'd be great too. Okay, we're going to do this one as a speed round, just so you guys get another example. And if you'd like me to do a couple more examples, just always feel free to reach out to me. I will absolutely do a few more examples for you. So let's get to it. Next example, we're going to have y equals -x squared plus 10x minus 23. Now what I always want to note here is that a is negative. So a is negative here, so I know it's going to be a downward facing parabola already. To find my AOS, again, x is equal to -b over 2a, -10 over 2, well, a here is -1 actually, so this is -10 over -2, which is equal to 5. So x equals 5 is my axis of symmetry. That's going to cut my parabola right in half. That x equals 5. Then what I'm going to do is I'm going to evaluate, and again, we're using this and plugging it in to find our vertex. Be careful here, the negative, and then we input the 5 in parentheses, squared. Very important. Plus 10 times 5 minus 23. Okay, this is going to be y is equal to -25 plus 50 minus 23. Y is equal to 25 minus 23, or y is equal to 2. So my vertex is 5, 2. Okay, and speed racer, my quick sketch. Fighting the clock here, only have less than a minute to go. It's going to be a downward facing parabola. I have my axis of symmetry, that is x equals 5. And I have my vertex, which happens to be here. This is a max, because it's at the top. Maximum. And that occurs at the point that occurs at the point 5, 2. It's not, let me write my 5. There you go. Hope you enjoyed the video. If you have any questions, shoot me a message.